In this lesson, we're looking at solving radical equations. This is section 7.6, so we're going to solve equations containing one radical and two radicals, and then sometimes they have two radical terms and a non-radical term. Okay? So you'll see what this looks like here on the next few slides. So examples of radical equations, we could have something simple like this where it's just a square root equal the number, and that you should know how to solve that. Cube roots, we're working with nth roots now, so we can go above a square root. And then something like this is going to be the more difficult case where you have two radicals right here, and then a non-radical term. Okay? So we're going to follow some steps here. So we're going to rewrite it so there's one radical on one side of the equation, and then we're going to raise each side to a power to get rid of the radical. So a power equal to the index. That's the little number inside the little check mark area. Okay? Combine like terms when we're done. If we still have a radical, then we're going to redo everything. Get the radical by itself again, square or cube, or we'll do whatever to both sides, and then we should be able to finish it out. Okay? So if you're a step person, always go back to those 6 steps to solving radical equations. But we're going to look at these two examples here, see how it works. Okay? So we have the square root of x equals 5. All right? So how would we get rid of a square root? Well, since this is a square root, we can take both sides and square it. Okay? And that's going to get rid of that radical. All right? So only for square roots can I square them like this. All right? And so I have x equals 25. And then you should be able to put that in here after everything is gone. Redo everything from the beginning. Put a 25 in here. And it does check out. Okay? Square roots are one of the things that you always want to check your answers because you could have something with a minus inside there, and you could end up with a negative in the square root. And remember, if we have something like this, at this point, this is no solution. Okay? So you want to double check your solutions in the end. All right? So this spot up here where it says examine for extraneous solutions, that means check it to see if your equations or your solutions work or not. Okay? So this one, what you might want to do, this is what I've seen a lot of people do, they just take this and they're like, okay, I can square everything and that's going to get rid of the square root. No, you cannot do that. All right? You're breaking the order of operations when you do that. You're doing exponents before you would do addition and multiplication in your steps to solving, which you can't do that. So what you have to do is get this by itself first, okay? So we would add 6 to do that. And then we would have square root x minus 4 equals 8. Now we have the square root by itself. Now we can take this side, square it, take this side, square it, and then that's going to get rid of my square root. So I have x minus 4 on the left, and I have a 64 on the right. And then simply solve it. Okay, back to algebra 1 here. Plus 4, we get x equals 68. All right, and then again, you can take that, plug it in here, and check it. So let's do that here quick. So square root of 68 minus 4 minus 6 equals 2. So that square root ends right there. So we have a square root of 64 minus 6 equals 2. Square root of 64 is an 8, minus 6 equals 2. That does check out. Okay? So that was a good answer for that one. All right, next one we're working with, we have a cube root up here in the top left. Okay? So I'll work through this one, and then you should be able to pause the video and work through the rest of them. Okay? So same thing, just like the last two. We have to get this by itself first. That cube root here in this case, we have to get that by itself. So we'll subtract 10 from both sides, and we get cube root of x equals, so 8 minus 10, that's a negative 2. All right, and then you want to cube both sides. All right, so that'll take care of that. And so that was the step in the solving equation step where it said raise both sides to the same power as the index. So my index was a third root, so I have to raise it to a third power. Those are going to get rid of each other. and then I would have x equals negative 8. Okay? If we were to plug that in, you can kind of do this step in your head. Cube root of negative 8 is a negative 2 plus 10. We get back to an 8. So that does check. Okay? So pause the video here and work through the next few equations on this slide. And then when you're ready to check your answers, replay and come back to it. All right, so for B here, you should have subtracted the 5 from both sides. So 2 minus 5 is a negative 3. And then here what you probably did is you went like this, because this is what we've been doing. You square both sides, and you're like, okay, x equals 9. Negative 3 times a negative 3 is a 9, and you had that for an answer. Hopefully, you double-checked your solutions here. Okay, because if I plug this in, I have square root 9 plus 5 equals 2. Well, what's the square root of 9? This would then be 3 plus 5 equals 2. That does not work. Okay, that is not a correct solution. So this is no solution for this one. So this is why you should double check. Sometimes you have to go through all the steps, and then you get an answer that doesn't work. And I can show you exactly why. In the process here, when we got to this step, okay, you will never have a square root give you just a negative, okay? If I square root something in there, square roots are always going to give me something that's plus or minus if we did absolute value, but it should always give us something that's positive, all right? So square roots should always be positive, okay? So right here is where we could have stopped and said, hey, that's not possible. There's no solution, okay? But it's important to check your answers. So next, 2. This one shouldn't be too bad. We already have the square root by itself. So square both sides here. 2y minus 1 equals 9. And then we finish this out. So add 1 to both sides. 2y equals 10. Divide the 2. And we get y equals 5. Double check that quick. If I plug a 5 into here, that's 5 times 2 is 10. Minus 1 is 9. So we have square root 9 equals 3. And that checks out here, okay? So this answer is good. It checked out. Cube root. How do we get rid of that cube root? Well, we have to cube both sides, okay? Because we have to get rid of that index. And then we have x plus 3 on the left and 2 to the third. That's an 8. And then to finish out, we'll have to subtract 3. And we get x equals 5. Okay? And this one, again, simple enough. I could just kind of do this in my head. 5 plus 3 is 8. Cube root of 8 is, in fact, 2. Okay? So there are those ones. So now we have something that's a little more complicated. All right? We have an extra variable involved, and that does really kind of complicate things. Okay? The steps are exactly the same, except you might have to factor sometimes, or you might have to FOIL. Okay, so these are some things that you might have to remember. Factoring, foiling. You might have to do those in the end, okay? So let's look at how we do these. We have a square root right here already by itself. So if the square root's by itself, you can take this step and square both sides, okay? And I'm specific when I say square both sides. I can't just square this and square this. That doesn't work. I have to square the entire side, okay? This is it's a step that people do incorrectly. That brings us to foiling, okay? We're going to have to FOIL here with this stuff. You can't just square the x and square the 3, all right? If you have something to the second power, how many times do you have to write it out? We have to write that out twice and FOIL, okay? The stuff on the left is easy. That's just going to cancel out that. Stuff on the right, when we FOIL it out, we get that. Okay? So after we square both sides, we are at this right here. Okay? And so now we have an x squared and a couple x's floating around. So that's going to bring us to this, factoring. All right? So we're going to have to put everything on one side. So we'll get a 0 on one side. We're going to move the 2x and the 3 over. So add 3, minus 2x. minus 2x. I'll just do both of those in one step. On the left, we have a 0. On the right, we have an x squared minus 8x plus 12. And now how do we factor something like this? Well, you have to think two numbers that multiply to 12 and add to 8. And that will be a 6 and a 2. And they're both going to be negative. So we want a positive 12, negative 8. Okay? And then how do we get our two answers from this? Well, we set them both equal to 0. This one is x equals 6. Set this one equal to 0. We get x equals 2. Okay? Then, definitely, when you get two answers, you should check them. I'm going to go back to the beginning. All right? We're looking at the stuff that we started with, and I'll kind of do it one at a time. So let's plug in the 6 first. So 2 times 6 is 12. Minus 3, that's 9. So we have square root 9 on the left. And then plugging in that 6 minus 3. So square root 9 is a 3 equals 3. That one's good. Now let's check the other one. So 2 times 2 is 4. Minus 3 is a 1. So you have square root 1. And then we have 2 minus 3 on the right. So square root of 1 is just a 1. 2 minus 3, that's a negative 1. So this one doesn't work. That answer is out. Okay? So that's why it was important to check both your answers, because sometimes you get two answers and only one of them works. Okay? We're going to end up with something similar over here where we're going to have to FOIL and factor. Okay? So let's look at B. What is our first thing that we need to do? Well, that square root is in the mix of everything here. And over here, I said we had to get the square root by itself. So same thing applies here. We have to move everything except for this. So let's move the 2. Let's move the x. Okay, that's out of here. That's out of here. And now we have this. So 2 plus 1 is 3 minus x. Okay, and then we're going to have to divide everything by a negative 2. Divide both sides by a negative 2. All right? So this one is kind of complicated. We haven't had a whole lot of stuff like this before. We haven't had a whole lot of stuff like that in our equations. Okay? So how do we get rid of the square root? Well, we're going to have to square both sides. We're going to have to square this. So you might be thinking, oh, I can just distribute the 2 through there. Well, no, we can't. I'm going to rewrite this stuff off to the right and show you how it's supposed to work when I square it. So if I square this whole side, it's going to be like this and this. So this is a FOIL on top. If we don't FOIL it, we're going to lose it. On the bottom, that's just a simple square. Okay? So from here, square root x squared, that cancels. So just an x. And then in the numerator here, how many times should we write that out? Twice. And this would be 9 minus 3x minus 3x and minus 6x plus x squared. Okay, that's in the numerator. So 9 minus 6x plus x squared. And then we have a positive 4 in the bottom. Okay. So we've done everything like this before, but just not all combined into one question. All right, so how do we go from here? So I don't want to factor anything up here yet because I would just get back to that 3 minus x. I would get back to where I started. So I want to get rid of this. How do I get stuff out of the bottom? I'm going to multiply both sides by 4. That'll take that out. And then we have 4x on the left. 9 minus 6x, and I'm going to rewrite that the other way around because I want that x squared first. So x squared minus 6x plus 9, and now we can put the 4x over there because now we're kind of on this, like this step here, where we have to get everything on one side. Okay, that'll get rid of that. And then we have 0 equals x squared minus 10x plus 9. Whew. Okay, that was a crazy step to get from here to here. So, factoring now. Two numbers that multiply to 9 and add to 10. That should be fairly straightforward. That's 9 and 1. x minus 9, x minus 1. So my two answers are, we set them both equal to 0. We get x equals 9 and x equals 1. And we need to check them. Okay, we need to check those two answers. So 9 and 1. We got to go all the way back up here. And I'm going to get rid of all my extra work. So plugging in a 9 here and a 9 here. So I'll kind of do this after the 9's plugged in. So this would be 9 minus, so square root 9 is a 3 times 2 is a 6. So does that check out? 9 minus 6 is 3 minus 2 is 1. That's good. The 9 is good. And then we check the 1. Okay, so plugging in a 1 here and a 1 here. So 1 minus 2 equals 1. Definitely not. The 1 does not work. That one's out. Okay, so go back down here. We had a 1. No more. Doesn't work. The 9 was good, though. Okay, so definitely make sure you check those solutions in the end. All right. So next round, we have a couple more of those. So these ones are a little bit different because if you're looking at these, I have a square root of 2 in there, not a square root of x. So this shouldn't be too bad to solving these, okay? So let's just try to solve this like we would a normal algebra 1 problem and get this x by itself, okay? So first thing we want to do is move the 1 over, and then I have x root 2. 3 minus 1 is a 2. And then how do I get the x by itself? Well, I need to divide that square root 2 from both sides. Okay? And so now this presents something like this. And the problem with this, remember, we can't have a radical in the denominator. So this is taking us back to our 7-5 stuff where we have to fix this. So to fix this, we have to rationalize. In a square root, we just take it times another square root. Okay? So on the top, we'll have 2 square root 2. On the bottom, this is a square root 4, which simplifies to just a 2. Okay? And then what happens here? I can simplify by taking those out. So x is just going to equal square root of 2. Okay? Seems kind of redundant, but that's how that one works. Okay? So next one here, we have something like this. So how do you think we'd go about doing this one? Well, there's a little bit of a trick here. If I weren't trying to get exact solutions, I could just put that in my calculator, change it to a decimal, add it with that one, and then I would divide it. But that's going to get me a rounded number, and I don't want that. There is an x here and an x here. How do I get them out of those two terms? What do I got to do? Well, remember, we can factor if we need to. So the x's are going to come out of there. That's the greatest common factor. So I have x out, and then I have square root 2 plus 3 equals 5. Okay? And then we got to get the x by itself. So we're going to divide both sides. Root 2 plus 3, root 2 plus 3. And that's out here. Okay? Now, this should remind us about another thing from 7-5, where you have to rationalize using a conjugate, okay? So a conjugate, what is that? Well, that's where we take the same numbers with a different operator in the middle. So a minus here versus a plus here. That's conjugates, okay? So we have to multiply by conjugates to simplify this one. And we're done on the left already here, okay? So I just have an x on the left, so I'll simplify this stuff out. So on the top, we have to distribute. So 5 root 2 plus 15. On the bottom, we FOIL. So square root 2 times square root 2 is just a 2, or square root 4, which turns into a 2, minus 3 root 2 plus 3 root 2. Remember, those are going to cancel out. And then we have a minus 9. So those are out of here. So 2 minus 9 is a negative 7. Okay? And we're almost done. I don't like negatives in the bottom, and really we shouldn't have negatives in the bottom. So to fix that, we just flip all of our signs. So this will flip that and that. And then we're done. If you left the negative in the bottom, that's technically not wrong for the answers that we're getting, but that's what we should do. Okay? Now, problem with these two. Well, this one's not bad. Problem with this one, If I want to check it, it is a nightmare to check, okay? So with something that ends up ugly like this, we're just going to go with our gut and say we did it right. If we get a simpler answer, okay, like this one, we could check that, because if we plug that in, that's pretty quick. So let's just look at it quick, all right? So square root 2 times square root 2 is just a 2. So you have 1 plus 2 equals 3, and yeah, that checks out. So this one's not bad to check, okay? All right, a few more here. So these ones look more complicated. So these are when there's two radicals involved. We have a radical on the left and a radical on the right. Looks kind of complicated, and these ones are actually not that bad until you get other things with them, okay? So ask yourself the same question. Do I have the square root by itself? Yes. If so, I can square both sides, the complete side. I can't square individual things. And now what happens when I square this? Well, it takes care of the square root. Same thing on the right. That takes care of the square root. All right? So now we just work to get the x's by themselves. So minus x plus 7. Okay, that gets rid of those. That gets rid of those. We have a 2x equals 12. And divide by 2, x equals 6. Okay? And that's going to work. Okay? One over here. 1/3. We have to remember what a 1/3 is. Okay, and I hope you remember that just switches to a cube root. It looks like this. All right? I don't need to rewrite it like that. Okay, I just need to understand what they are. Because if I know that this is a cube root, then how do we get rid of a cube root? Well, we're going to take both sides and raise them to a 3rd power. That's going to cancel out that index. Okay? And you can see here, power to a power, same thing. We multiply those, they cancel to a 1. Same thing over here. So x plus 4 equals 3x plus 10. And now work to solve. So move the x's to the left like we just did. Move the numbers to the right. Those are gone. So negative 2x on the left and a 6 on the right. Divide the negative 2. X equals negative 3. Okay? And these should be fairly decent to check. You should just be able to plug it in here. Negative 3 plus 4, that's a 1. So 1 to the 3rd root is just a 1 on the left. Plug it in here. Negative 3 times 3 is a negative 9 plus 10, and we get a 1 over here again. So yeah, that one checks out. Okay? So, something like this. If I have a number in front, okay, I'm still going to kind of do the same thing because I have a square root by itself. So I'm going to go ahead and square both sides like this. And now again, I say square both sides, okay? So this one is a little bit tricky. That square needs to go to the 3 and the radical, all right? And I know before I said I can't distribute a square. That would be if I had something like this, okay? I cannot distribute squares here. So this one would have to be FOIL, and this one is distribute, the exponent. The difference is huge. It's that little plus sign right there, okay? That does not allow me to FOIL, or does not allow me to distribute a power, okay? This is multiplication over here, so I can distribute that power. Now I only have to take it to that radical and the 3. Okay, so this would be 9, and that square root would cancel, and I would essentially turn that into parentheses. And over here, squares cancel. And this is where we're at. Okay? So, next step would be to distribute the 9 on the right. And then we're going to have to move stuff around to get it equal to 0, because we're going to have to factor. We got an x squared, we got an x. Well, we might. I have to see a 9x squared here and here. Those are probably going to cancel. Okay, which they are. If I move this over, those are going to cancel out. So that actually turned out a little bit nicer. So let's add the 18. Those are out of here. So 18 plus 6, 24, equals 9x. And this looks like we have 24 ninths, which I'm going to have to simplify. We can take a 3 out of that. So that would be 8 thirds. Okay. And I think we're just going to go with this one. You should be able to check the 8 thirds here, but it's kind of a headache because it's a fraction, but it will work. Okay? So we have a couple more left. All right, so stick with me. So we have here where there's 2 radicals, right there, and 1 non-radical. Okay? Same rules apply. Get one of the radicals by itself, square both sides. Okay? And we have to square both sides. And remember, on this one, on the right, I'm not going to be able to distribute that square because of the minus. Pluses and minuses do not allow me to do that. So what you might want to do right off the bat, write it out twice, and then get ready to FOIL. Okay? And we'll review how to FOIL one of those. So right on the left, we got a 2y minus 3. And on the right, we're FOILing. So this times this, that's just going to cancel to a 2y plus 3. Okay, because the square roots cancel, everything's just going to double itself. All right? Then we're going to go to here. So that would be a negative 1 square root 2y plus 3. And then we have another one of those, negative 1 square root 2y plus 3. And then negative 1 times negative 1 is a positive 1. Okay, and then we got to remember how to simplify here. So we can move things around, but I'm just going to combine things on the left and the right. So 2y minus 3 on the left. On the right, I don't have any other y's, so I'm just going to leave that as 2y. I have this 3 here and this 1 here. I can put those together to make that plus 4. And then I can put this with this because they're matching radicals. So it'll be minus 2 square root 2y plus 3. Okay? And now this is like the step 4, I think, that we had to do. So we have a radical floating around here still, even after squaring it. So now we go back to step 1 and get this by itself. We have to work to get that by itself. So we have to move everything away from it. All right? So I'm going to keep that circled so we remember that. So move the 2y over, and conveniently, that cancels the 2y. Okay, let's move the 4 over, kind of take care of 2 steps at once here. And then that gives us a minus 7 on the left. Then we have negative 2 square root 2y plus 3. Okay, now we got to get rid of that negative 2. So divide both sides by negative 2. That gets rid of that. And the double negatives cancel. Okay, and then we're going to write our work over here. So on the left, we have 7/2. On the right, we have square root 2y plus 3. Now, square root by itself. What's our next step? Square both sides. Okay? How do we square a fraction? Well, you just square the top and square the bottom. So that would be 49 fourths on the left, and we have a 2y plus 3 on the right. Okay? Here's where, if you don't like to do fractions, then use the calculator. We're going to do this without a calculator so we can remember how to do this. So minus 3 from both sides. Okay. Maybe I'll put that like this so I know I'm subtracting 3 from that. So subtraction of fractions, I must have common denominators. So this is like a 3 over 1. And I need a 4 on the bottom. So this would change this to a 12 over 4. So we're doing 49 minus 12. That gets me to a 37. So we have 37 over 4 equals to y. Okay, and I'm kind of messing up my work here a little bit. I got more room. Let's move this down here. How do we get rid of the 2? Well, we divide it. Okay, but rather than dividing, this might look a little bit nicer. Dividing by a fraction is the same thing as multiplying by its reciprocal. So let's multiply both sides by a half. And then I get 37 over 8. So we get y equals 37 over 8. And again, this one might be best just to kind of use a calculator and change this to a decimal and plug things in to check it. We're just going to go with it and say that it does work because we have a good feeling about the steps that we did. Okay? So recap a little bit on this one because the next one is going to be similar. I have to square both sides. And since this one has the -1, that's what really makes this more difficult because I have to FOIL this here. All right? That's what we did here. That's why I wrote it out twice. We have to FOIL. Okay? And then when I FOIL, I get to this step right here. And that's where I combine like terms. Then we get to this step after we've combined. And then we work to get the radical by itself like this. Okay? And then we're back to step 1. Square both sides, then solve for y. All right? One more of those, and then we're done. Okay? So this one, I have 2 radicals on one side. So back to step 1. Do we have a radical by itself? No. We have this radical with this radical. You have to have a radical by itself. So we're going to move this one over. And I can simply do that just by adding the opposite, because remember how we add radicals. If they match, we can add them. So let's put that square root 3x minus 2 on the right. Okay, so now we have square root 5x minus 1 equals 1 plus square root 3x minus 2. Okay, now we have a radical by itself. Next step, square both sides. And I know if I'm squaring stuff on the right, I'm foiling it, so that's why I'm just going to write it out twice right away. Okay, from here, same steps as the last one. So square root cancels here. On the right, we FOIL. So 1 times 1, 1 times that square root. And then this square root times 1, so that's the same thing. And then square root times square root. Since those match, the square root cancels out, and we just have 3x minus 2. Okay? Combine like terms on both sides. On the right, we have a 1 and a negative 2. Let's put the 3x in front. So 3x minus 1, the minus 1 comes from this and this. Okay? And then we have 2 of those radicals. All right, what's the next step? We got to work to get this by itself. So we have to move everything around. And now this looks like the x will not conveniently cancel on this one, so we have a little bit more work with this one. All right, so move the 3x over. So that gets us a 2x on the left. We'll put that 1 over as well. And that'll cancel out. That'll be kind of nice. Okay. And we have left just that. And I don't think, this one looks like it's not going to be that bad. So how do we get rid of the 2? Well, we just divide both sides by it. And that conveniently cancels that over here as well. All right, now we have x equals square root 3x minus 2. The radical is alone. We can square both sides. And there's not a whole lot of work on the left because that just squares itself. Okay? Let's move our work over here. On the left, we got an x squared, not a third, squared. And then 3x minus 2 on the right. Now put everything on one side. And guess what we're going to have to do here? We have a trinomial, which means we're probably going to have to factor. So 2 numbers that multiply to 2 and add to 3. Negative 2, negative 1. And we get 2 solutions. X equals 2. And we get those again by studying this equal to 0. X equals 2. X equals 1. And what should we probably do if we get 2 solutions? And these work out nice. These are easier ones to check. So let's check them quick and then call it a day. Okay, so I'm plugging in a 2. This would be 10 minus 1, so we get square root 9 from that. Plugging in a 2 here, that's 6 minus 2, square root 4. So this would be a 3 minus a 2. That checks out. All right, let me give myself a little bit more space. Then the other one was the 1 that we had to check. So this would be 5 minus 4, or excuse me, 5 minus 1, square root 4. Plugging in a 1 here, 3 minus 2, that is a 1. So this is a 2, this is a 1. 2 minus 1 does indeed equal 1. So this one, they both work. Okay? Whew. So this is how you solve radicals. This is pretty much how you solve most of the radical equations that you're going to run into in any Algebra 2 class, Algebra 1 class, intermediate, and a little bit of pre-calculus. Okay? So if you enjoyed this video and all the examples in here, please give me a thumbs up and subscribe. Thank you for watching. Have a great day.